Good morning, YouTube. Welcome back to the lab. Okay, so in the last episode we built this. This is a clone of this. And this is a glorious distortion pedal. And if you haven't seen me build this, skip back one episode. You can watch me build it and listen to how it sounds. What we're going to do this episode is take this and actually install it into a Eurorack module. And we're going to do this so we can put this into a Eurorack case and use it along with all of our other modules. Okay? Let's get started. Right. So, as I was building this thing, I had a little bit of an epiphany. It occurred to me that I'm almost done building this, and this board is almost done. And this board is ultimately going to end up in a box like this. It's a guitar pedal. The board is going to go inside. I'm going to put the jacks in. It's going to have 1/4 inch guitar in and out, and it's all going to be powered by 9-volt battery. Now, all that's fine if you're a guitar player. This form factor really works well for guitar players, but I am primarily a synth guy, and especially a modular synth guy. So this doesn't make any sense to me. This form factor doesn't make sense, right? What actually does make more sense for me is something like this, right? This is a blank Doepfer panel. Instead of taking this board and putting it in something like this, it would be better if it actually fit behind a panel. Like if I could get this thing either like this, or better yet, mounted like this behind the panel, something like that, right? 2 of these. All that sounds great. The other big problem that I see is that this is designed to work on 9-volt. This is also 9-volt, but if you look on the inside of a Doepfer power supplies, you see that right there, the Doepfer system actually runs on plus or minus 12 volts. So that is a bit of a problem. You can't just connect the Doepfer directly to the 9-volt here. You'll put too much voltage into it. That's not good for the parts. Fortunately, we have these things called voltage regulators. So the way this works is you can feed it 12 volts or any range of voltage that it supports. This can support up to 18 volts, I think. So you give it 12 volts on pin 1, pin 2 is ground, and pin 3 gives you a 9-volt output, which is perfect for this. So this is a Doepfer box, and this is the cable that comes out of it. The cable is something like this. There's the red line on the bottom, and there's minus 12 volts there. There's plus 12 volts on the top 2 pins, like so. And then the middle ones are ground. So all these in the middle of a Doepfer cable are actually ground, these 6. So if you take the plus 12 and you feed that to pin 1 on a voltage regulator, like the one that I have here, this guy, and you take the ground and you connect it to the second pin of the voltage regulator, then that third pin is actually going to give you a 9-volt output, which is what we want. You can take the 9-volt and run it into the power input along with ground. And in theory, with this, you should be able to power this, and the rest of it should be pretty easy. It's easy enough to use one of these jacks, these 1/8 inch jacks, instead of a 1/4 inch jack. That's easy enough to replace. I already have the knobs. These, you can drill the holes in here and just bolt them on here. That's easy. The only other problem that I see here potentially is figuring out a way of getting this thing on here, but I'll figure something out for that. I think though this method is gonna work. So I think I'm gonna try that.
All right. So This was a simple enough build that I dispensed with a breadboard and just went straight to a prototyping board. A prototyping board is something you can buy at any good electronics store, and it lets you take your various components and build something that's a little bit more permanent than a breadboard prototype. In the case of this board, you have to actually connect them on the back with short lengths of wire to get all your parts connected. In some cases, you can get a board with long lanes that are already connected, so then you can just solder your parts on there and you're done. The lanes actually end up connecting all the parts together the way that you want. One thing to keep in mind here is that when you work like this, make sure to have your multimeter out and check continuity. Just make sure that the things that you think are connected are actually connected on the board. It's good to get in the habit of doing this because as you work on more complex projects, troubleshooting becomes more and more of a headache. It's always easier to check your work as you go rather than waiting until the end. When you're done, you can use a coping saw to cut the fiberglass board down to size. It's fiberglass, so make sure that you clean up after yourself. You don't want to breathe this stuff in or get it on your skin. Now here I made a quick mock-up in Illustrator of what I think the front panel should look like with the general spacing, and taped it to the front and used that as a guide to drill pilot holes and progressively bigger and bigger holes to fit all the jacks and knobs that are going to go into this product. It's important to start with really small pilot holes because that's the only way you can get an accurate hole where you want it to go. If you start with a big drill bit, your bit is going to wander around and you're going to end up with holes all over the place, and it doesn't look neat or tidy. Finally, when you're done with the holes, you can go ahead and connect the parts to the front panel. This part, if I had known how this was going to look, I would have kept the cables for the potentiometers and the jacks a little bit shorter. That's a lesson learned. Next time I'll probably keep things a little bit shorter because I ended up having to tuck the cables under the module, which isn't really great practice because the module can get caught on things when taking it out of the case. And finally, you can see our power board connecting to the rat pedal to give it that 9 volts of power. In the end, I decided to take the power board and actually tape it to the back of the case and not the module itself. And the reason I did this is because I have quite a few guitar pedal kits that all run on 9 volts, which means if I leave that inside the case, I can use that same board to power all of my other 9 volt kits. And finally, I marked everything up with a permanent marker so I know what's what, and we are good to go. Okay, so here we have the Rat distortion pedal mounted up in its own module. Here we have my modular synth. All this is doing is creating some 808 kick, snare, and hat sounds using the tip-top audio modules. I'm triggering all that with the grids from Mutable Instruments, and finally we've got the micro brute here. So the kick and the snare from the tip-top audio are coming through this pedal and out to the computer and being recorded. Okay, and those sound like this right now. Clean, no distortion at all, very clean. The hats, which are not going through the distortion pedal, sound like this. Okay, I generally don't like the sound of hats being distorted, so it's too much high frequency sound for me. So these are going straight to the computer with no distortion being applied. And finally, the micro brute is going through the Music Thing modular spring reverb, which I built back in episode 1. You can skip back to see that if you'd like. And that thing sounds like this. Alright. So now that this is doing its thing, and you know how everything is arranged here, let's turn up some distortion and see what we can get on the kick and the snare. Remember, the hats are not distorted here. Even with a little bit, it gets a lot more thick, a lot more creamy. And this is only about a quarter of the way up. We can keep pushing this. Get some really, really nice, kind of grungy that's when you start hitting that industrial territory, which I really like. Okay. Back off the volume a little bit. And maybe this is a little bit too bright, so we can use the filter here to bring down some of the high frequency sounds. And right there, I already love this. The cool thing about this setup is that the kick and the snare that are being routed into the distortion, all three of these are working together, right? So if you rebalance the kick and the snare, like you bring down the level of the kick, the sound of the snare getting distorted actually changes too. All of these things are working together to create this kick and snare sound. So if you back off the kick, all of a sudden the snare sounds a little bit different. Or if you lay into the kick, the kick is eating up all of the headroom and not leaving much space for the snare, so that's starting to get really kind of squelchy too. Extra prominent if you turn the filter off on the rat pedal. But yeah, and you can really push this into quite extreme territories. It's very, very distorted here. Back this off. And this is quite extreme, but I mean, it might be the right thing for certain types of music. And so there you have it, folks. Rat pedal, been converted into a module. It works. It sounds great on drums. We heard in the last episode that it sounds cool on bass too. Probably sounds good on other things too, but I haven't had a chance to try it yet. Looking forward to doing that. I hope you have enjoyed this episode, and I hope you will tune in next week. If you've liked it, please go ahead and click subscribe and click the like button. And more importantly, tell your friends. It's kind of a geeky subject, this, and the more people we can get involved and the more discussions we can have around this stuff, the better it is for everybody, I think. So anyway, thanks again for watching, and I will catch you in the next one.